clean this burette by using tap water, distilled water, and in this time we are going to add our HCl solution into this burette. Usually we adding the solution which has known concentration to this burette. However, in this situation only we will use our HCl unknown concentrated HCl solution into this burette. Okay, so I have to clean by using water, tap water, and next with distilled water. After that I have to rinse this with small amount of titrant, which means HCl. So I already clean with tap water and distilled water. I will rinse this with a small amount of our HCl solution. Okay, first of all I have to close the tap. Okay, I will add small amount to rinse. Okay, okay, I have to get it's into the horizontal position, and I will clean like this. Okay, okay, it's now rinsed. Now I have to fill it. Please careful. When we are filling this, we have to get it down to the down. It should be lower than our eye level, because if we fill it on the this desk, when I filling, some chemicals will spill into my eyes. Because of that, we are not doing that. We will keep it lower than our eye level, and I have to use a funnel to fill. Okay, and I will fill like this. Okay, now I have to wash my tap also. I will open the tap and the level will come down, and I will adjust the meniscus also. Okay, now meniscus is very perfect. I will show you the meniscus of burette also. Okay, now you can see it's very clear. The meniscus is very perfect. Okay, now my burette is ready. Okay, my burette is ready. Now I can do the titration with my prepared standard sodium carbonate solution. Okay, let's go to the titration. Now I am going to do the titration. Now my burette is filled with acid, HCl acid. I don't know the concentration, and I will do my titration with this sodium carbonate, standard sodium carbonate solution. So here I have my titration flask. Okay, I will get known volume of this sodium carbonate solution by using this bulb pipette. Okay, so I will take 25 milliliters of this sodium carbonate, 0.01 sodium carbonate solution into this titration flask, and I will use phenolphthalein as my indicator, because we are using the strong acid HCl and strong base sodium carbonate. For strong acid, strong base titration, we can use phenolphthalein as the indicator. So first of all, I have to take small amount of our sodium carbonate solution to a container, because we have to rinse our bulb pipette. I will take a small amount. Okay, 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 I took small amount. I will remove the filler and I will rinse the pipette like this. You can see. Okay. 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 Now I will measure precisely 25 milliliters. Okay, now it's okay, 25 milliliters. As I said previously, my pipette should be in vertical position and the conical flask or any other container should be in angle. This is the correct practice of using bulb pipette or any other pipettes. Okay, now I have to remove, I keep side and okay. Now I have my base sodium carbonate 0.01 m solution. I will add indicator of phenolphthalein. 1 drop is very sufficient. Don't add too much. I will add 1 drop. Okay, I added 1 drop. You can see it's pink in color in basic medium. So I am going to do the titration. So to indicate the color we have to use, to clearly see the color we can use white tile, and I will do the titration. So I have to keep my hands like this. I will handle the titration flask with my right hand, and I will handle this tap by using my left hand. Okay, so I have to vigorously or continuously shake the titration flask while I adding drop wise this HCl solution. Okay, let's take a look. Come. Okay, now you can see how can I handle this. I will handle my hands like this, and I will open the tap, and I have to mix it very quickly, and I have to add drop wise. Actually I will add drop wise. You can see drops are dropping, so I will shake very vigorously and continuously. Okay, we have to do 3 trials. However, I will demonstrate only 1 trial. Your initial burette reading is 0 in this scale, and I will read the end point. I will show you that. Now the pink color is somewhat decreasing. Okay, my end point will be very close. You can see the color of the solution. Color of the solution is very pale color, pale pink. Now end point is very close, so we have to add drop wise. Okay, I add 1 drop, and I will add 1 drop and shake, add 1 drop and shake, add 1 drop and shake. Likewise we have to add drops very carefully. Okay, now it's very pale color. You can see the color is very pale, very pale color, pale pink color. Okay, the color change is pink to colorless. So I add 1 drop again, 1 drop, 1 drop, again I will add 1 drop. Now very pale color. Okay, now it's colorless. As you can see, now it's colorless. I will show you. Now the solution is colorless. Previously it was pink color, now it is colorless. Now I will read the burette reading. Now it's here, it is 10.04. Meniscus is on the 0.4, 10.04. That's the volume of our burette reading. Actually, that's the end point reading of our burette. So now it's very perfect. Okay. Now our titration is finished. Okay. Now you know how to do a titration very precisely. Okay. We got the endpoint. Important things we have to add in first trial. We will let dropwise because we don't know the endpoint. So we will let dropwise. Second and third trials we can do fast because in first trial we know the endpoint. In second time we will add very rapidly and final volumes, final milliliter will be at dropwisely. Okay, that's the thing. Now I know the volume of the burette reading. That means HCl volume. At first, in this conical titration flask, we had 25 milliliters, 0.01 m sodium carbonate solution. We know the concentration of that, and we can read the number of moles. We know sodium carbonate and HCl will react according to stoichiometry 2:1. 2 HCl will react with 1 sodium carbonate molecule. However, in this first reaction, what happened? The sodium carbonate will convert into sodium bicarbonate. So now the solution contains sodium bicarbonate solution. So total sodium carbonate is not already, that means sodium bicarbonate should convert into carbonic acid to fulfill the reaction, to get the total reaction. First reaction is sodium carbonate will react with HCl and will produce sodium bicarbonate. Now this sodium bicarbonate will react with again HCl and will produce carbonic acid. That is the end of this reaction. So now the solution contains sodium bicarbonate. Every sodium carbonate converted into sodium bicarbonate. Now I will do the reaction again with HCl, but I have to add another indicator. So this indicator should be its pH range should be lower than phenolphthalein. So I will use methyl orange as the indicator. Okay, it is the suitable indicator. So I will use methyl orange again. At that titration, I can measure the volume required from HCl to neutralize sodium bicarbonate. So let's add 1 drop of methyl orange and we will do the titration again. Okay, come. Now I have methyl orange indicator. So in basic medium, methyl orange color is yellow. We are doing titration with HCl. So this solution contains now sodium bicarbonate. We will add 1 drop of methyl orange. We will see the color. it is, you can see it's clean yellow color. Okay. Now this solution contains sodium bicarbonate. I will titrate further this sodium bicarbonate with HCl. After neutralizing sodium bicarbonate, solution will be acidic by addition of HCl. So acidic color of this methyl orange will be red color. So we will do the titration until the color change yellow to red. Okay, we will do that very quickly. Okay, we know the stoichiometry 1:2. So to convert sodium carbonate into sodium bicarbonate, if we need V1 volume, same volume will be needed for converting sodium bicarbonate into carbonic acid. So 10.4 previously we got the measurement, now it should be 20.8 because according to the stoichiometry. Now you can see still it's yellow color, but now it is very pale yellow. Now the reading is nearly 20. Now the color change is very close. The solution will convert into red color. Actually light red mean peach color. Solution is still yellow, but you can see the yellow color is converted into something. Okay, what's that? Now we got the end point. Now solution turn into another color. Now it is look like somewhat you can see it's like orange color, but now it is the end point. Yellow color converted into orange mean now it is pale red color. You know the acidic color is red color. Now solution contain light red, that mean light orange color. Actually we call that peach color. This is the end point of our experiment. Okay, it's not yellow color, actually it's peach color. Okay, okay, now we finished our titrations. To get a clear idea about these color changes, this is the basic color of phenolphthalein. It is pink color, it is very clean. When we add acids, its color will fade and it will turn into this acidic color of phenolphthalein, that means colorless. Okay, phenolphthalein will colorless in acidic medium, and basic color it is pink color. So this phenolphthalein, original phenolphthalein is in acidic medium, that's why it's colorless. On the other hand, we have methyl orange. Methyl orange in we know methyl orange will be red in color in acidic medium. So this methyl orange is acidic medium, because of that its color is red color. Its basic color will be like this yellow color. Okay, initially we saw that our solution was yellow in color. This is the initial solution of first yellow color. After titrating, when we add excess amount of HCl, it will be acidic. So basic color is yellow. In basic medium it is yellow. When it is acidic, it will convert into red color. So this is the peach color, actually initial red color. The concentration of HCl very low, because of that it is very light red color. We call that peach color. This is the end point. You can see clearly the color changes. This is yellow and this is peach color, that is the end point color of sodium carbonate titration. If we add more and more HCl, this solution will be red color because of acids. You can see that we add more and more HCl, so it will concentrated, and you can see it will be more and more red color when we adding excess HCl. You can see that. Okay, I wanted to show you the color change initial peach color was the correct endpoint. Now HCl is very excess, so very red color. This is not correct because we added more amount of our HCl. So initial peach color I show you, that's the correct endpoint. So those are the color changes, very perfect, and that's the thing you have to know. Okay, now we are in our conclusion part. First thing is lab safety. I used always this safety goggles and these gloves, and I wear my lab coat. So I got all the precautions, safety precautions. After that, I prepared primary standard solution using the standard solution using a primary standards. I told you about primary standards and their characteristics. I measured them by using our balance correctly, and I transferred quantitatively into the volumetric flask, and I prepared stock solution. After stock solution preparation, I used a small amount of stock solution to prepare 25 milliliters to prepare our working solution. Working solution, we used working solution for our titration, not the stock solution. Okay, working solution means lower concentrated one. We prepared these working solution from stock solutions which has higher concentrations. We are not using higher concentrated stock solutions to titrations, using lower concentration working solutions. Okay, initially we put 25 milliliters of this working solution into a titration flask, and we add initially phenolphthalein indicator, because in first reaction this burette contained HCl solution, and in our titration flask we had sodium carbonate solution. In first reaction, sodium carbonate converted into sodium bicarbonate. To indicate that reaction, we use phenolphthalein because its pH range was in between 8.3 to 10. So strong base, strong acid reaction, we use phenolphthalein. After sodium bicarbonate preparation forming, we did our titration further. At that time, sodium bicarbonate converted into carbonic acid. That's the second step of the reaction. To indicate that we can't use phenolphthalein because now pH range is very low, so we used methyl orange indicator. Its pH range in between 2.9 to 4.6. So endpoint or equivalent point of that second step was lying at that pH range. Because of that we use methyl orange. In basic medium, sodium bicarbonate shows this yellow color in basic medium. We titrated with HCl. After endpoint it indicated red color or peach color. That's the endpoint of second step. So that's the completed titration. So we got two burette readings, first for phenolphthalein, second for methyl orange. So volume is doubled. When we are using methyl orange, volume was doubled, because in phenolphthalein we got only one step, sodium carbonate into sodium bicarbonate. We got 10.4 milliliters. To convert into carbonic acid, again we have that same volume of HCl. That means 20.8 milliliters for methyl orange. So 10.4 for phenolphthalein, 20.8 for methyl orange, because when we are using methyl orange we have to add double volume of our acid HCl. So that's the conclusion. So you can do the calculations. We know the concentration of our sodium carbonate solution. We know the volume of HCl by reading this burette reading. So easily you can calculate the concentration of our unknown HCl solution. So that's the end of two experiments, the standard solution preparation and titration. Okay, let's meet in another video, another titration. Okay, so goodbye for all of you, and ayubowan.